Hello viewers, we are the students of SVCW of CSE branch. Now we are going to present a video on free space management presented by B. Sivaharshita 22B01A0510 and G. Sivatmika 22B01A0541 under the guidance of Dr. M. Prasad, PhD, Associate Professor, Department of CSE, SVCW, Bhimavaram.
Today, our topic is free space management. Now, coming to the introduction part, free space management is a critical aspect of operating systems as it involves managing the available storage space on the hard disk or other secondary storage devices. The operating systems uses various techniques to manage free space and optimize the use of storage devices. Now coming to the techniques, free space management techniques consists of five. First one is linked allocation, contiguous allocation, indexed allocation, file allocation table, volume shadow copy. Now coming to the first one, linked allocation. In this technique, each file is represented by a linked list of disk blocks. When a file is created, the operating system finds enough space on the disk and links the blocks of the file to form a chain. This method is simple to implement but can lead to fragmentation and wastage of space. Contiguous allocation. In this technique, each file is stored as a contiguous block of disk space. When a file is created, the operating system finds a contiguous block of free space and assigns it to the file. This method is efficient as it minimizes fragmentation but suffers from the problem of external fragmentation. Indexed allocation. In this technique, a separate index block is used to store the addresses of all the disks block that makes up a file. When a file is created, the operating system creates an index block and stores the addresses of all the blocks in the file. This method is efficient in terms of storage space and minimizes fragmentation. Fourth one is file allocation table, which is also called as FAT. In this technique, the operating system uses a file allocation table to keep track of the location of each file on the disk. When a file is created, the operating system updates the file allocation table with the address of the disk blocks that make up the file. This method is widely used in Microsoft Windows operating systems. The fifth one is volume shadow copy. This is a technology used in Microsoft Windows operating systems to create backup copies of files or entire volumes. When a file is modified, the operating system creates a shadow copy of the file and stores it in a separate location. This method is useful for data recovery and protection against the accidental file deletion. Overall, free space management is a crucial function of operating systems as it ensures that storage devices are utilized efficiently and effectively. The system keeps track of the free disk blocks for allocating space to files when they are created. Also, to reuse the space released from deleting the files, free space management becomes crucial. The system maintains a free space list which keeps tracks of the disk blocks that are not allocated to some file or directory.
After allocating files in the hard disk, there is a free space available in the hard disk. So how OS manages the free space is it assumes that a file is deleted. Then we will get some free space. So that space will be added to hard disk. So OS will allocate that space also in order to allocate memory for the files. In this system, we will see how OS manages the free space which is available in the hard disk. So for that we have four approaches. The free space list can be implemented mainly as big vector linked list, grouping, and counting. So the first approach is bitmap or bit vector. We know that hard disks contain a collection of blocks. In these blocks, the file information will be stored. Here, each block is represented by a bit. If the bit is 1, then it specifies that the block is free. If the block bit is 0, then it specifies that the block is occupied. So, a bitmap or bit vector is series or collection of bits where each bit corresponds to a disk block. The bit can take two values. They are 0 and 1. So 0 indicates that the block is allocated and 1 indicates a free block. Here, which is shown in figure 1, where green blocks are allocated, can be represented by a bitmap of 16 bits as 0, 0, 0, 0, 1, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1, 0. So, by looking into the figure, we can say that the green blocks are zeros and the blocks which are in white were ones. Advantages of bitmap. In this approach, it is simple to understand and easy to implement. It occupies less memory as its size is small because in each block we have to maintain that whether it is occupied or empty with the help of a single bit 1 or 0. By finding the first free block, it is efficient. It requires scanning the words, which means a group of 8 bits in a bitmap for a non-zero word. A zero valued word has all bits 0. The first free block is then found by scanning for the first one bit in the non-zero word. The second approach is linked list approach. In this approach, the free disk blocks are linked together. That is, a free block contains a pointer to the next free block. The block number of the very first disk block is stored at a separate location on disk and is also cached in memory. In figure 2, the free space list head points to block 5, which points to block 6, the next free block, and so on. The last free block would contain a null pointer indicating the end of free list. Advantage of linked list is no wastage of space, which means no need of extra space here because we are having some blocks. In those blocks only we are maintaining the links. And the drawback or disadvantage of linked list is the IO required for free space list traversal. For traversing, it will take large amount of time. For example, if we are having 100 blocks, if we want to traverse to the last block, then we have to traverse all the 99 blocks before 100 block. The third approach is grouping. This approach stores the address of the free blocks in the first free block. The first free block stores the address of some, say, n free blocks. Out of these n blocks, the first n minus 1 blocks are actually free, and the last block contains the address of next free n blocks. So the advantage of grouping is in this approach, the addresses of a group of free disk blocks can be found easily. The fourth approach is counting. In addition to next free block pointer, keep a pointer saying how many blocks are contiguously free after that block. It is also slight modification to linked list approach. In linked list, we are having pointer in each block to maintain addresses. In addition to that, it is better to maintain a variable called counter. So that counter specifies after that block how many free contiguous blocks are there. For every block, in addition to maintaining the next block addresses, it is better to maintain a count variable which specifies how many free blocks are there after that particular block. So this approach stores the address of the first free disk block and a number n of n contiguous disk blocks that follow the first block. Here every entry in the list would contain addresses of first free disk block and a number n. The advantages of free space management. Here there are mainly three advantages of free space management. They are: the first one is efficient use of storage space, and the second is easy to implement, and the third is faster access to files. So, coming to the first advantage, efficient use of storage space. Free space management techniques help to optimize the use of storage space on the hard disk or other secondary storage devices. The second advantage is easy to implement. Some techniques, such as linked list allocation, are simple to implement and require less overhead in terms of processing and memory resources. The third advantage is faster access to files. Techniques such as contiguous allocation can help to reduce disk fragmentation and improve access time to files. Disadvantages of free space management. Here, there are mainly four disadvantages of free space management. The first is fragmentation, and second is overhead. Third is limited scalability, and the fourth is risk of data loss. Coming to the first disadvantage, fragmentation. Techniques such as linked allocation can lead to fragmentation of disk space, which can decrease the efficiency of storage devices. And the second disadvantage is overhead. Some techniques, such as indexed allocation, require additional overhead in terms of memory and processing resources to maintain index blocks. The third disadvantage is limited scalability. Some techniques, such as FAT, have limited scalability in terms of the number of files that can be stored on the disk. The fourth disadvantage is risk of data loss. In some cases, such as with contiguous allocation, if a file becomes corrupted or damaged, it may be difficult to recover the data. So, overall, the choice of free space management technique depends on the specific requirements of the operating system and the storage devices being used. While some techniques may offer advantages in terms of efficiency and speed, they may also have limitations and drawbacks that need to be considered. Thank you for watching our video.
If you like our video, please like, share, and subscribe.